Okay, students. So, continuing, in the same lecture, till here we wrote these three ratios become equal. Ax upon xy is equal to ab upon by is equal to ac upon yc because of result 1 and 2. Now, in 9th standard, you have studied the theorem on equal ratios. See a nice combination of 9th standard syllabus and 10th standard syllabus in this sum, 10th sum, important sum. Theorem on equal ratios says that if the given number of ratios are equal, then each ratio can be equal to adding the each ratio is equal to a ratio obtained by adding the numerators and the denominators of the remaining ratios. So AB and AC when I add and BY and YC I add, I get another ratio. This ratio is equal to the first ratio. This is a theorem on equal ratios which you studied in 9th standard. Put values. Ax upon xy is 5 plus 4 upon by plus yc is bc because b dash y dash c as you see in the diagram. Ax upon xy is, that is why 5 plus 4 is 9 and bc is 6. Cancelling in the table of 3, 3 2s are 3 3s are, we get the ratio ax upon xy equal to 3 by 2. This is the sum number 10th. Very important sum. This type of sums they can ask a combination of different types of properties and even previously studied properties. Now we will solve sum number 11. So students, this is the 11th sum. It is said that ABCD is a trapezium where side AD is parallel to side BC and diagonals AC and BD intersect each other at point P. We have to prove that ratio of side AP to PD, AP to PD is equal to ratio of side PC to BP. Okay, this seems to be a familiar sum because we have solved such type of sums earlier. Okay, so how to do it? We will write in the proof. If you recall similar sums earlier we have solved, we used to prove these two triangles similar. In triangle APD and triangle, be very careful while naming the other triangle, APD and triangle CPB. In this triangle, okay, we have a pair of vertically opposite angles congruent. So angle APD congruent to angle CPB, vertical angles, the vertically opposite angles, any reason you can write, and we have, therefore sign will not come, and we will now have two pairs of corresponding angles if we consider these two parallel lines and the diagonals as respective transversals. Which are the angles? Angle ADP will be congruent to angle CBP and angle DAP is congruent to angle, if it is DAP, it is BCP. So congruent to angle BCP, and you know how to write the reason. Alternate angles formed by transversals. Which are the transversals? AC and BD. Okay, or BD and AC of parallel lines. Which are the parallel lines? AD and BC. Parallel lines AD and BC. So what we get? Because of these three angles of one triangle congruent to three angles of the other triangle, the triangles become similar. Therefore triangle APD will be similar to triangle CPD. Which is the test? The test is AAA test, AAA test of similarity. Now when the triangles are similar, we know the corresponding sides are in the same proportion. So AP upon CP or PC, whatever you can say, AP upon CP is equal to, okay, we want AP, PD, PC, BP sides. So we'll take PD upon, because it is triangle APT and triangle CPB, sorry, this is triangle CPB. Initially we made a mistake. CPB, yeah, it is triangle CPB. So PD upon PB. The reason is corresponding sides of similar triangle. Now we didn't get this ratios equal. So you have to recall the properties of equal ratios you have studied in 9th standard. Which property will be applicable to get AP upon PD? Numerator upon numerator is alternando. So by using alternando, AP upon PD is equal to PC or CP. It is one and the same. PC upon PB or BP. This is by using alternando. Okay, it is again a property of 9th standard. So we got the required ratios to be equal. Understand? AP upon PD is equal to CP upon PB. So what to do? Prove the two triangles similar by triple test and then write the ratio of the corresponding side, and after that use the property of alternando to get the required proof. This is the 11th sum of problem set 1, and now we will solve the last sum of the problem set, sum number 13. So the entire problem set will be solved with these sums 1 to 5 and 9 and 12 sums left with you to be solved. So now sum number, dear students, sum number 13 it is. Triangle ABC is there with angle A of 90 degree. Square DEFG is such that all vertices DEFG lie on the sides of the triangle ABC. This is given. We have to prove that DE square of DE is equal to BD into EC. BD into EC. All are parts of the hypotenuse BC of right angle triangle ABC. But what you have to prove? DE square is equal to BD into EC. This is what we have to prove. No construction is needed, so we will write the proof. So in the proof, what we will do is, first we will consider the big triangle BAC. But before that, it is said that this is a square. So we first mention quadrilateral DEFG is a square. It is given. Understand? This is given. Now as it is a square, all its sides will be equal. So side DE, okay, therefore side DE is equal to side EF is equal to side GF is equal to side GD. All the sides are equal. Sides of square. Sides of square. And this is result number 1. Now what we will do is, we will consider the big triangle BAC. Okay, in triangle BAC, and what I am doing is, I am considering a small triangle, but this triangle BDG, and you know how to maintain the correspondence of the vertices. In triangle BAC, A is right angle, and in triangle BDG, D is a right angle, and B is a common angle in both the triangles. So in triangle BAC and triangle BDG, what I will write? Angle B congruent to angle B, which is a common angle. It is a common angle, and we also see that angle BAC is congruent to angle BDG because both are right angle, each is 90 degree. So because of this, what happens? The triangles are similar. Triangle BAC is similar to triangle BDG. Which is the test? It is AA test. Okay. Now you know, when the triangles are similar, what we can do? We can write the corresponding sides in proportion. But here we are not writing corresponding sides in proportion. We are giving this result number 2. Now, as we have proved these two triangles similar, we can prove triangle BAC and triangle FEC similar, not congruent, similar, sorry. So we can prove triangle BAC in triangle BAC and triangle, I am very careful while writing the name of the other triangle. I want this triangle. So BAC, A 90 degree, here E 90 degree, and C is common angle in both the triangles. So I will write the name of the triangle from F. So triangle BAC and triangle FEC, which is the common angle C congruent to angle C, common angle, okay, And which are the right angles? Here BAC, angle BAC is right angle which is congruent to here FEC, which is right angle. Okay, so reason is each is 90 degree, same like previous step. So we see that triangle, okay, BAC is similar to triangle FEC. Again by which test? AA test. Now we see here, this is result number 3. Now use the transitivity property. If one triangle is similar to the other triangle and other triangle is similar to the third triangle, then the first triangle is similar to the third triangle. That is the property of similar triangles we have studied in the earlier lectures. So by transitivity we say that triangle BDG is similar to triangle FEC. Correspondence is automatically mentioned and maintained also. This we get from result 2, 3, and one more reason we will write transitivity. Which property it is? Transitivity of similar triangles. Understand? Now after this, like we write the ratio of the corresponding sides. Which sides we will write? We write the ratio BD upon EF. BD upon EF is equal to DG upon EC. Okay, third pair of side is not needed. Corresponding sides of similar triangles. Now you know that this DG is equal to EF, which is already mentioned in first, because they are the sides of the square. So this GD or DG is replaced by EF, so that we get the required thing. Okay, so what I will write is, now I will write BD upon EF. Okay, BD upon EF is equal to DG is replaced by EF. EF upon EC. This we get from 1. Okay. Now what will happen? Because of this, what will happen? If I multiply, it is EF square. Which is that? EF square. EF can also be replaced by, I should have replaced this EF and this DG by required thing DE. I made a mistake here. So both these things needed to be replaced by required thing DE. So I will write DE, and here also I will write DE. This I will get from 1, because GD and EF both are equal to DE, and so I replace DG and EF by DE. Okay, this I get from 1. Now on cross multiplying I will get, I am writing here, DE into DE is DE square. Therefore DE squared is equal to BD into EC. BD multiplied by EC. This is how we can get the required thing to be proved. Okay, so how to remember this sum? In this, first we write that this is a square, DEFG is a square, so all sides are equal, result number 1. Then prove triangle BAC, the entire triangle, similar to small triangle BDG by AA test. And again, triangle BAC, the big triangle, is proved similar to triangle FEC. Okay, and then by using transitivity, these two triangles, smaller triangles, are similar. That is triangle BDG similar to triangle FEC. They are similar, and then we write the ratio BD to EF is equal to DG to EC, corresponding sides of similar triangle. And then this EF and DG both are replaced by the required side DE, because GD and EF both are equal to DE. So remaining things remain same. BD upon DE is equal to DE upon EC from 1, and on cross multiplying we get the required thing. So this is the sum number 13, important sum. Okay, and many extra sums from the old syllabus, okay, can be asked in the board examination. You know that in geometry paper of board examination, question number 4 and question number 5 may contain some external sums. Okay, these sums will be related to your chapter, but they will not be found in your textbook. They may ask these sums from the older textbooks. Okay, so find out the older textbooks always, you should have mathematics part 1, mathematics part 2's older textbooks. Okay, 5 years, 10 years old textbooks. from those textbooks also they can ask you the sums, okay, related to this chapter. So for question number 5 and question number 4 of your board paper, you need to practice extra sums also. Today, like this, we are completing the entire chapter problem set 1 with this completion of problem set 1. The entire chapter 1 is over. Sums I have given you homework, few sums are homework, but they are easy sums, all can do it. Now, as chapter 1 is over, I am planning to give you test on this chapter. So the test will be like sent to you, test papers will be sent to you on WhatsApp. You people will have to keep the test paper solved, and when we will meet in actual class, I will correct your papers. Okay, till then, take care of your health. Bye bye. Good day.